Hi, I'm Bruce Clark, General Manager of AI-TEK. For over 50 years, AI-TEK has been providing reliable, predictable, cost-effective monitoring and control devices for some of the most demanding speed sensing applications on planet Earth and off. AI-TEK started life as AirPaks, a small industrial division of Fortune 100 companies. We are now privately owned, boasting all of the quality systems of those larger companies and the personal service and entrepreneurial spirit found in the best small companies. We are AS9100 ISO 9001 certified, and our sensors are made in the USA. I hope you will find the following training helpful in gaining insight into AI-TEK, the company, its products, and numerous applications we serve. Thanks for your interest in AI-TEK. Welcome to AI-TEK Instruments Profile Training Series. The first section, Company Introduction. Here we're going to discuss a little bit about AI-TEK and where we come from and who we are. We're located in Cheshire, Connecticut on about 34 acres, 136,000 square feet for the whole building. We occupy about 35,000 square feet of that. It is it's our corporate office and general plant. AI-TEK is AS9100 ISO 9001 certified, and we have a couple of different products and markets that we serve. And we start with the variable reluctance. It's a passive sensor, and we'll be talking more about that in future segments on this. And we do Hall effect sensors, and they come out as single and bidirectional technology products. We also have a good complementary product called a tachometer. And that, again, that's a complementary product to the sensors. It talks with the sensors and gains information from them. We serve a lot of different markets: military, aerospace, rail, power generation, petrochemical, and industrial. And you can see we have a fairly good family of parts that we make. And give you a little idea of what or where we come from, really. AirPaks started back in 1946 building black box controllers for aircraft, and that was in California. And through the years we've changed a lot of names, we've changed a lot of different things. Back in the 1960s we launched our speed sensor products, and that was down in the Fort Lauderdale area. And then kind of fast forward to 1986, that's when most of the products came up from Fort Lauderdale into Cheshire. That was again around 1986. In 2000, Siemens acquired Montezemont VDO, and that was pretty much the end of AirPaks as we know it, because in 2002, the owner group of AI-TEK purchased what was remaining of AirPaks. We couldn't use the name, so we use AI-TEK. The AI in AI-TEK stands for AirPaks Instruments. And from 2002 to 2017, we've been making speed sensors and tachometers here in Cheshire. We've been very busy along the way, and we talked about the product or the evolution of our company over in the left column. So back around 2000, a lot of things started happening. Montezemont VDO sold us to Siemens, and then Siemens again sold us. That's when AI-TEK was formed. And then we transitioned basically into AI-TEK. We couldn't use AirPaks anymore. And around 2010, 2009, we acquired Temptron. And that's a division that we have that makes mil-aero sensors, thermocouples for aircraft. The next one over is a product line that we actually no longer support, and it's aircraft black box and indicators. When we took over as AI-TEK, we really opted out of that business. It was something that we weren't going to be able to support anymore, and we wanted to put our full effort into our sensors and tachometer products. Moving over the passive speed sensors. Passive speed sensors, it's a very mature technology. It's a technology that you can see really doesn't change along the way. Essentially it's just showing really through the mid-1970s through present, the same coil wire bobbin technology really hasn't changed a whole lot. It's really the materials you use, how reliable it is, the special designs that you do to fit into mil-aero and industrial and the high temperature applications, hazardous locations. It's really the way the product is presented to the outside world that kind of changes. But the basic sensing technology really hasn't changed too much. That's in contrast to active speed sensors. Active speed sensors have a history of changing considerably. And you can see in 1970, that's really when we started active speed sensors, and it started out life as magnetoresistive technology, and then that moved on to tangential field design, which was used in automotive sensors, and then differential field Hall effect, and then all the way up. You know, these days what we're looking at is self-calibrating designs, differential field, EMI hardened. The technology increases. The problem with that is that an active speed sensor really doesn't get the opportunity to have a lot of different or a lot of time behind it. So where a VR sensor or a passive speed sensor, you know, you can claim that it's had decades worth of experience on it. The active sensors don't really get that, and that can actually affect what people buy, how their buying decisions. If it's an extremely critical application, a lot of people will tend to stay with the passive speed sensors as they make their purchase. And moving over, you know, we started out with speed switches and tachometers. Our first generation tachometer back in 1970s was a microprocessor-driven tachometer. That's when the first use of TAC-PAC and TAC-TROL came out. That product, I'll tell you, that lasted us very, very well into the mid-2000s. And quite honestly, if we could keep buying the material that we used in those days, it would keep getting chips, the electronic devices that go onto the PC board, we would probably still be making it now. But as time marches on, you know, what we ended up doing, we redesigned that, the Gen 2. It is also microprocessor, but processors these days, they're higher bit count, they're faster, they're more accuracy, that type of thing. We added USB and RS-485 connectivity, and you know, we retained the TAC-PAC, TAC-TROL name. And then moving forward past that is Gen 3. We're talking about that now. It's in the discussion stages. Again, another microprocessor-based tachometer, but now it'll begin to integrate industrial networks, smart filters, failure detection. They just keep getting better and better. And looking over at our third-party certifications, there really kind of is a view of how the company is viewed by other people. So we have third-party certifications that, you know, we can go to a customer and say, you know, we say we're good, but, you know, by the way, UL, CSA, FM, you know, all of the quality organizations, they all say that we're good too. So you can see back in the 1970s, we were big into UL and CSA. Those were North American standards. And they were good, but as time marches on, you know, we had to add, we kind of fast forward a little bit. We're into AI-TEKs now, IEC-EX and SIL, that's safety integrity level. Our quality systems have also moved forward. Back in the late 1980s, you know, ISO came out, and then we moved into QS to satisfy the automotive world. And then, you know, as we were AI-TEK, we needed to keep moving too. So we've got AS9100, which is an aerospace standard for our quality systems, and that allows us to work in the aerospace world. So we keep moving forward both in technology and quality systems. A little bit about you know, the structure of the company, some key people to talk to. Along the top, these are our customer service, marketing administrators. You'll either deal with Karen Liss or Sharon Solocious. They've been with the company for a very long time and are extremely well versed in all aspects of our products and service. The one thing to note with Sharon, how we do customer service. Now if you have a technical issue, if you have a question, you call into Sharon, or you come in through the technical questions, this info at AI-TEK Sensors that you can get from our website, or you call this number, 6000, that's our main number. It'll get to Sharon. Sharon makes sure that the call gets to the right people. Engineering handles that. So you'll see, you know, we attempt to kind of compartmentalize the problems. They're experts on different fields, and they'll make sure that you get the service that you require. Along this row here, you've got the president, myself, and the engineering manager. The three of us, if things aren't happening, if you need help, if things aren't moving in the direction that you think they will, which I doubt that will happen, but if things aren't moving or you need extraordinary help, give one of us a call. We will help you out. We'll make sure things get done. All right, so AI-TEK, we've got a lot of customers that we've had, OEM customers, past and present. And you know, if you start looking over all the different names that are on this, this slide, a lot of these names change so often, it would almost be impossible to keep this slide up. But you know, you'll recognize some names, and you know, all of a sudden, Allied Signal, you know, Honeywell, and how the mil-aero market changes a lot. But anyway, this is just to kind of give you an idea about the types of people that we have worked with over the years. Automotive, you know, we dealt with Ford and GM. GM, really, we don't have too much work with right now. Ford, we've got some small programs, but we are not an automotive company. We're not looking for new automotive programs per se. And so, you know, we maintain the equipment to build some aftermarket and spares and that kind of thing, but we're really not an automotive company. We do governors. These are the devices that are used on, you know, engines to regulate their speed. It used to be done with a mechanical device. Now it's done electronically, so our speed sensor is that connection to that world. Industrial, this list here, there's only 4 players that are listed here, but really this would take over pages and pages. A lot of what we have is sold through distribution, and you really don't get to see where a lot of these applications go, but you know, there's a wide range of applications. Mixers, you know, Elliott, Barbara Coleman, some big names in the industry. For mil-aero, again, a long list. We've been on some very high-profile programs, and we can go over those a little bit more, but you can see, you know, for Honeywell, BAE, Boeing, Garrett, Hamilton Sundstrand, Honeywell, Northrop Grumman, Parker Hannifin, Rolls-Royce, Tank Command, and Thales Aviation. So we've been working with a lot of the big names in the mil-aero industry. Off-road trucks, a lot of this, you know, we go into the transmission that goes into the off-road truck. There's actually this Allison transmission. This is really more of a that's would probably fit under a mil-aero, because that's a military vehicle that we're servicing there. Caterpillar, we're making a sensor that goes not in the product itself, but it is a device that's used when they're testing their new engines. They've just built the engine, they rack them up in a temperature chamber, and they use our sensor to help make sure that the engine is running correctly before they commit it to product. Dresser Rand, Euclid Hitachi, Letourneau, you know, they're making large off-road industrial, you know, you've seen the big earth movers with the huge tires and everything. You know, a lot of these are being used for traction control and anti-lock brakes for those large vehicles. Petrochemical industry, you know, all the big names, BP, DuPont, ExxonMobil, and Valero. A lot of these petrochemical plants utilize, and we'll talk about this a little bit more on the next page, but you know, a lot of these use pumps and other rotating equipment, and so these places are perfect for applications for our products. Utilities, GE, Pratt & Whitney, Westinghouse, they're all making these, you know, power generation skids, turbine-driven generators, and we're not involved in the utility, so the distribution side of it, but it's in the generation side of it. And so there's a lot of equipment used in that generation side that can be used. And the Argo was making devices that help in the distribution of, let's say you have a gas turbine. Argo was making the equipment to help move that equipment or move that fuel. And so they had some use for our speed sensors as well. In rail, you have Alstom, that's a big name over in Europe. Bombardier, they're over in the United States, all over. General Electric, General Rail. We've also actually, this is not entirely complete. We have Mitsubishi Electric and Siemens. We've been on a lot of different rail applications. Most of our sensors, you know, we've developed sensors that are specifically designed to survive in the rigors of rail applications. This is kind of taking a look. I don't want to spend too much time on this kind of stuff, but you know, you look and see the same applications, the same markets. but specifically more the applications rather than the companies that are buying them. And so, you know, when you look at the aero, we're on a lot of auxiliary power units, both on airframe and ground, helicopters. We're on the rotor for a number of helicopters, the H-60 Black Hawk, AH-64 Apache, the T-55 Chinook, we're on the rotor. So we're in a lot of different things. We're on the space shuttle. We were the effluent pump for their toilet. So a very, very critical application, triple redundant, very, very important. Automotive and off-road. It's more off-road than automotive, as I'd mentioned before, so we don't want to get too deep into the automotive thing, but you know, there are a lot of applications where you see, you know, heavy equipment, recreational vehicles, buses, fire engines. You know, in the transmission, we have a side look sensor that we'll talk about in another module, and you know, so there are still these applications, but they tend to be lower volume. A lot of it is spares and aftermarket, but there's still good business there to be had. On the industrial side, again, this list really could take up pages, and again, the listings here are really just to kind of give you an idea of some of the applications that we go into: mixers and agitators, conveyors, compressors, you know, all kinds of stuff, centrifuge, anything rotating. We interface with PLCs, our tachometers. You know, they'll take a sensor and a tachometer, and the analog output from the tachometer will interface with the PLC and give it speed control. Motor controls, assembly systems, which kind of goes into the conveyor systems a little bit, flow meters, HVAC systems, winders. So anywhere, again, where there's rotating motion, the speed sensor has an application. We're in marine vehicles, where, you know, engine control systems, propulsion, fire pump, bilge pumps, you know, again, marine, a lot of rotating equipment, a lot of applications there. Consumer products, we really don't do too much with consumer products anymore. At one time we did have this for an exercise machine, but consumer products is not a big part of our repertoire. Military vehicles, you know, we're on tanks and transports, a lot of application there. Petrochemical, again, steam turbines, fans and blowers, pump drives, air compressors. The petrochemical industry, really, there's so much out there. You go into a single refinery or a single you know, petrochemical plant, and there are these just endless sections where either the user is looking to upgrade and add speed because it wasn't there before, or on a regular basis they're constantly going in and redoing and refurbishing this equipment. And so this is a good opportunity to get in there and to be applied to those applications. In the rail industry, traction control, so on the locomotives, speed control out back on the trailer cars, along with these data recording systems. Utilities, and we're not in the distribution side of it, but again, utilities are using so many of these turbine generators, gas, steam, geothermal, pumps. They're using tons of this stuff, so all good applications. Here's a slide for the mil-aero crowd. It gets into a little bit finer detail, some of the high-profile programs we talked about, the Black Hawk and the Apache and the Chinook and all that. You know, when we were back making the industry indicators, we were on the F-14, F-16, F-18 fighters. We're on the F-22 now on their air starter, on the space shuttle. We're on the Abrams tank. We're on the Humvee. We're in Seawolf, the Virginia-class nuclear submarine. So again, a lot of application. The center table really describes what our sister company that makes thermocouples, the types of programs that they're on, and quite honestly, it's a good synergy when you can, you know, measure speed and temperature on the same engine. As you're going through and experiencing, you know, looking at different applications, you'll also see that there's a lot of competition out there. And we do understand our competition for the most part. I've grouped these based on frequent exposure and infrequent exposure. The infrequent, I wouldn't really worry about too much. A lot of that stuff tends to be higher volume too, and it's not really something that we get into. But you know, certainly in the mil-aero, you know, you're going to see Honeywell, you're going to see Skirka, you're going to see Dynalco. You're going to see Goodrich, on starter generators, especially the smaller ones. We see Jacquet and Krauss Maffei and the larger industrial stuff, Electro Sensors, Leonard and Bauer. All these guys, they're out there, and we are typically competitive with them. So, if you have any questions as you're going along, give us a call. We'll talk it through. We'll figure out, so in some of these cases, such as Dynalco and Electro, we actually have crosses that we can use. A lot of the part numbers or the function anyway on the sensors is identical. So you can do good direct crosses for some of the companies out there. All right, so one of the things when you're dealing with our sensors, you'll be exposed to our part numbering systems. And I don't want to spend too much time on this, but if you look at our active Hall effect part numbering system, we started out, there is some method to the madness, I guess, so that it is a semi-significant part number. So the first two characters, define the actual series. 1990s through 2005, really, we had the H series, which was our first differential active speed sensor. Right now we have an RH series. You're probably familiar with that. That's a single channel, single element, low level calibration device. Came in around mid-2005, and it's still active now. BH series is our bidirectional sensor, and DH is a differential Hall effect, and it's the newer. It's not necessarily going to replace the RH, but it's certainly it'll replace the RH in certain applications, and those need to be understood. And then the rest of the part number tells you if it's customer catalog, what the output style is like. Use this slide as a reference, really. As you go over to the passive sensors, there's a lot of history there too. The 7082 series, automotive and side look. We don't really do too much, again, as I had mentioned, we're not doing too much automotive anymore, so you won't see too many new 082 sensors. Same with the 083, 084 even, so those series, what you'll see most of activity is in the 7085, the standard 1010, there's an 8080 series, and then there's a 3030 series that added IEC-EX. That's a whole part number series devoted just for the IEC-EX type hazardous location sensors. And then of course our 086 mil-aero, that's just again to give you an idea what the part numbering is like when you get exposed to these numbers. As far as applications, future training courses, such as we go into variable reluctance speed sensors, active speed sensors, and tachometers. Right now, we'll just kind of go over some of the applications that you'll see out there, and so we do talk about rotating objects, and so pumps and that type of thing. But a few off-centered applications that we certainly can work with. And here this particular slide is showing the use of flow meters. You got a couple of slides here showing flow meters. And so flow meters utilize speed sensors. Our speed sensors can go in there, but also our tachometers can be used to read the sensors. So if you have a flow meter, you're probably not worried about RPM, you're worried about gallons per hour or gallons per minute or something like that, the flow rate, some sort of volume per unit time. And the tachometer allows you to provide or to do math on the signal coming in so that you can have the display show in gallons per hour or gallons per minute or whatever. And so it allows us now not just to show speed, but we can show flow. The standard typical rotary motion, you're looking at different targets on here. There may be a key slot, there may be a gear with multiple teeth. We can even take signals coming off of rotary encoders. And so there's a number of different ways you can get speed out there. If you're looking, here's a paper coding process where you've got really two encoders, and you're looking at the relative speed of one encoder to the other, and that allows you to kind of define, you can take a look and see if there's any stretch or slip or whatever, and if you're comparing the two speeds, the tachometer allows you to do that. Some more applications showing, you might have two different spool diameters, and so you're looking at the two speeds, and you can use the tachometer. We can not only pick up the speed, but you can use the tachometer to compare the speeds to see, provide a, make sure that the ratio is correct. Make sure the two speeds are correct, make sure that, an element hasn't broken that would then change the speed between the two. If you've got a HVAC system, you've got an FD and an ID fan, you might want to take a look at the speeds of those two fans. You may want to take a look at some ratio. You can then maybe derive flow rates from that. So again, another off-center application, but certainly not just pure, take a look at a shaft and see what speed it is. You can actually then take that speed information and convert it into something maybe that really is more effective for the customer. Got an application here with a rotary pulse generator. That rotary pulse generator can be looking at a lot of different things. It's not just speed. If you know how many pulses you have in your diameter, let's say, and you can do some math on the tachometer, you can actually then determine how much material has been fed over a given period of time, or you can take the element of time away altogether and you can just use it for measurement. So 1,000 pulses went by, and 1,000 pulses equals maybe 6 inches, and so you can use the tachometer, calculate what the displacement is of that material. And we talked about ratios. For more ratios, draw an extension. So keep in mind, it's not just simple speed application. You can do other things with that speed in order to control or monitor a process. A couple of the programs that we're on, again, this is just a sampling, but the Great Lakes Dredge and Dock, they've got ships, large ships out there that perform these dredging operations all over the globe, really. And they use our speed sensors in their pumps, in their dredging operations, and they use our speed sensors and our tachometers there. Another one, we talked about a lot of the mil-aero stuff. Just here's a slide that kind of sums it all up. And again, some very, very high-profile programs. We're on Taiwan Rail. Up here is a Mitsubishi Electric set of bogie wheels, and they've got our speed sensors up here, and they're monitoring the speed of the train, speed and direction. Tesla, we're not on the Tesla vehicle, but we are on production equipment that utilizes our bidirectional sensor when they're assembling their drivetrain. And so again, we're not on product, but we're on production equipment that is used to produce the drivetrain for Tesla. All right, that's it. We finished up with this. Please, for more training, please check out other in the series. We do variable reluctance speed sensors, active speed sensors, and tachometers and accessories. Thank you.